today I'll be going over some SQLite commands that'll help you understand the relationships that we covered in SQL in lecture. So for example, one-to-one, one-to-many, and many-to-many relationships. So let's get started. Let's get into my SQLite shell. So let's start off by creating a table called user. That'll have an ID, and it will be a primary key, so it will be unique. And one thing that we want to mention is that in SQLite, actually, auto increment is not really necessary, because if you say primary key, SQL will automatically recognize that as something that will auto increment. In fact, if you specify auto increment, SQL will use a different algorithm to increment the ID, but you shouldn't worry about it, and for now you can just omit it. And we'll also have a name. Alright, so we can check that we added the user, and we can also check that we actually have the columns that we want. So this is a command that you can use to see the columns, what you name them, and what data type they're expecting. Alright, so to actually demonstrate a relationship, we should create another table, and let's create a profile table. So this will be a one-to-one relationship because each user should have one profile and each profile should have one user. So it will have an ID, status, for example, like if the user is online or offline, and of course we need to reference the user ID. So the keyword unique just means, okay, the profile ID uniquely maps to a user ID, and that's how we can maintain this one-to-one relationship. And of course, we need to reference our user ID to say, hey, I'm referencing some external key here, and make sure that it's mapping from this profile table to the user table. And as usual, we can verify. And we can do pragma, and we see that we have the columns that we expect. Alright, so now let's try inputting data into our tables. So let's first insert into the user table, and let's say I want to insert myself. So we can select all from user, and great, I'm there with the ID of 1. Remember that SQL starts incrementing IDs from 1. And we can also see if we have anything in profile, and we should expect nothing, and that is correct. So let's try to insert data into the profile table with some status and reference it to some user ID. And right now the only user that we have in the table is me, and my ID is 1. So let's say my status is online, then the only ID that I should be able to add is 1. So if I select all from profile again, I instead should see this data of online, and it references the ID of 1 to the user ID of 1, and it has an ID of its own. Alright, so let's also insert another piece of data, but just with Connor, and also create a profile for him. And he's just happens to be not online, so he's away. And his ID is 2. We know that for a fact because IDs will increment by 1 naturally, but we can verify this anyway. So Connor's ID is 2, and we should see that away is directed to 2 of the ID of Connor. Alright, and I can now select from profile wherever the user ID is 1. So this shows you how useful it is to map IDs of other tables with tables like profile, And we'll show you more examples later with one-to-many and many relationships. So this gives us what we expect. And if we try to insert into profile, like so, we'll actually get an error. So this is the unique constraint failed. And this just means that we're trying to insert data into a user ID that already has data on its profile. So this is why earlier we mentioned that the user ID should be unique for each profile. All right, so now that we've covered one-to-one relationship, let's go with one-to-many. So a good example is songs and albums. So one album has many songs, but one song does not have many albums. So let's create our album table. And this is just saying I'm going to give my album a name and an ID. And we can do dot tables, and we see that our album table is there. We can create our song table. And we need to have the album ID so we can reference which songs belong to which album. And this will be an integer. And we have to declare that this is a foreign key. Otherwise, it will just think that this is some random album ID. It's not actually referencing the ID of the table album. And dot table should show me I added song. All right, so let's try to insert some data. So let's insert into album. And Connor gave an example in class with Kanye's album, so let's just go with that, Graduation. And let's also insert into song. And note that we require album ID, and that makes sense because a song has to correspond with an album. And this is some song name, and this should actually throw an error because we don't actually have the album ID, but SQLite doesn't enforce many things, so we can check out what's happening. So it actually just added in the ID for us, even though we don't have the ID of 1,000 in albums. So be careful with that when you're working with SQLite. Another thing I wanted to mention was in lecture 2, I said that there's no Boolean type in SQL. You would just use an integer where 0 represents false and 1 represents true. But you actually can you make up types like bool or boolean. And when I say that, it means that SQL is dynamically typed, so it will accept any value, no matter what you say it is, integer or text. It just so happens that SQLite is dynamically typed, but most databases will enforce type constraints, so Postgres will do this. But the reason why we told you that to begin with is to show you the advantages of using a database, and that would be to enforce types so that you ensure that data is consistent. But it just so happens that SQLite does not do this, so also keep that in mind. All right, so let's actually try to insert good data, so that we expect, and also more songs. So if we select from song, we should see the songs that we have. All right, and we can do more cool things. And this is just saying, hey, let's get the name of the song where it belongs to the album Graduation. So this is the number of songs, so that's 2, and that makes sense because we have Stronger and Homecoming right here. All right, so now that we covered one-to-one and one-to-many, let's talk about many-to-many. So a good example of this is the relationship between students and classes. So many students can be enrolled in a course, and many courses can be on a student's schedule. So let's create our student table. And as you can probably tell, this is feeling a little bit tedious now. And actually, our next lecture will go over how we minimize this. So stay tuned. And now here's my course table. Great. And this should show me, yes, I have student and course. So we need to create a table that essentially has both the student and the courses. So unlike before, where you could just have one table reference the other, the many-to-many relationship is different in that you need to have kind of like a middleman or in-between table. So we can call that enrollment. And as you suspect, it will have two foreign keys, unlike the previous two examples. Of course, it will have its own ID, but here I'm referencing the student ID and a course ID, and I need to say, okay, these aren't just random student IDs. I'm actually referencing the ID of the student table. Likewise for the course. Oh no! So I misspelled reference, and this means I gotta retype the whole thing. But that's okay. Okay, there we go. Great, so we should see that we have enrollment, and there we have it. So to demonstrate the beauty of the enrollment table, we gotta insert some data. So let's insert data into our student table. Let's say ABC123 is the net ID of a student. And let's do another student, DF like 456. And if we select all from student, we should see those values, and that is correct. Now let's insert into the courses. So insert into course title, values, and let's say CS 1110. And let's also add another course, this course actually. And if we select star from course, we should expect the data that we added. All right, so if we select all from enrollment, we should expect nothing right now. And that is true because we need to make that establishment of connection between the students and the courses. So let's add data into enrollment. And this makes sense because each semester students take different courses, and you yourself take different courses. So you're going to have to add data for enrollment in each semester. And here I'm just adding some data. And this can actually be easier if I just up arrow. And if I select all from enrollment, we can see all the data that we just added. All right, so now I'm going to create a join table. So the reason why we had enrollment was to establish that connection between the student ID and the course ID, but that's not really helpful information. I want to know the students' names that are taking these courses. So we can create a join table. So note that you won't have to do this for the course, but it's quite important to understand this regardless, and it's also quite interesting. So Here I'm just saying I want to know the course title and the student net ID so that I know, hey, these students are taking these courses have these students. So from enrollment, I'm going to do an inner join. So don't worry too much about this, but it's just interesting to see what you can do with a many-to-many relationship. Course ID, and then you can inner join that on the student, on enrollment. So this is just saying what you want to join by, so that, SQL recognizes these variables and that they're just not some random ones. And there you go. You see that ABC is taking 1110, also 1998, and DEF is taking 1110. And that's exactly what we did over here. So we did insert into enrollment, whatever student gets whatever course, and that's reflected right here. All right, that concludes the SQLite demo. So now I'm gonna get into our Python demo. So let's go do that. All right. All right, so I'm actually gonna give a tutorial on virtual environment because a lot of people have been having issues with that. So a virtual environment is necessary so that we keep all our dependencies and packages in one place, so the things that we're developing within one project doesn't conflict with the other. So if you notice, we have requirements.txt that's used so that you can load in the packages that you need for your virtual environment. But before we do that, let's install virtualenv. So virtualenv will help us create that venv folder, venv, that we will activate and load our dependencies in and then deactivate whenever we don't need it. So let's create that. Note that you can name this to anything you want. You can call this Backend venv, whatever, 1110 venv, but we recommend just venv. Great, so you see venv appears in my current directory. So let's step into it. So as you can see next to my cursor, I have parentheses venv right here, but I don't really have the modules or the dependencies libraries that the course required that I need, because we outlined that in requirements.txt and we haven't loaded that in yet. And you can actually see this. So if you go into venv and then you go into bin, you can see what you have already installed. So that's just Python and pip3. So as of now, I can probably just run a Python script, but I can't run the code that's in the starter because we're using Flask. And so this is why requirements.txt is so important. So you can do pip install -r requirements.txt. Note that you're doing this when your virtual environment is activated. Otherwise, it defeats the purpose of encapsulating modules or file or packages in this virtual environment. So as you can see, Flask is getting installed. And if I step into venv again and then into bin, wow, Flask is there. That's really cool. Okay, and note that I can step out of my virtual environment anytime with the keyword deactivate, but it's, for now, let's keep it activated because we'll be running our code later. All right, so that was a quick refresher on virtualenv. Let's get started in the Python demo. Great, so this is the demo. Okay. All right, so this is the empty demo. Sorry, that earlier before was what we filled out in lecture. But let's start off with db.py. So if you notice, what you've been doing for P2 is you go through all the rows in the cursor and you construct this object with keys, ID, description done, and then you fill in the data with the rows. But we can minimize this with some helper function, and it will become clear later once I type these out. So this is creating the object that I was showing before. and this is iterating through the data that I'm getting. So that was like row at index 0, row at index 1, row at index 2, so those would be columns. Great. And then I just want to return this. And now that I've created the object, every time I'm appending this object onto a list called tasks, and we can abstract that into another function called parse cursor. And this is the same idea, but I'm just abstracting it out so I could use this function anywhere I need it to be instead of copying code. Alright, so now that we have that, we can go in and edit the code wherever we're having to parse things. So for example, in get all tasks, we can get rid of this. So instead of setting tasks and then appending it, we can set it to the method that we just made. And now we only need to pass in the fields, as that was what we described up here as the columns. All right, so that was that. It looks like we can fix more places with these functions. For example, like get task by ID. We can use return parse row, and then we just only need to pass in the fields. And that looks good. All right, so let's get into the actual demo where we create another entity that allows us to explore the idea of relationships. So let's go with subtasks. This would be a one-to-many relationship because a task has many subtasks and a subtask references only one task. So let's start off by creating our subtask table. So I'm just going to do a try catch statement. In case anything goes wrong, I can print it and see what happens. And then let's actually make the SQL query. And this would just be create table as you've seen before. It will have an ID that will be unique and auto-incremented. And then now we have to actually reference that task ID. And how do we know task ID isn't just some field, average field like description or done? And again, that's by using the foreign key. Saying that, okay, this is actually referencing the ID from the task table. And you can't forget the semicolon. And there we go. So this is great. So create subtask table. If you recall earlier in our constructor, we create the task table, and likewise we'd have to do that for the subtask table. So that's called once. You only need to create the table once, and that makes sense. All right, so now we can get into functions that can interact with our subtasks. So like getting all the tasks, we can get all the subtasks. So let's create a method for that. And you've seen this before. You get the cursor. And getting all subtasks is as trivial as select star from subtask. And using that function that we made before, parse cursor, this becomes very easy to do. and then we can just return subtasks. So now that we can get all the subtasks, how about we insert the subtask? So wherever the client gives us in the posts data, we can populate our subtask table. So this will just take some fields that will define a subtask. As usual, we will have the cursor, and we want it to execute insert into subtask, and then all of that data that we just got. And this is just naming the columns. And we have to commit this to make sure it actually gets added into the database. And whatever subtask we just added to our table, we have to return that. That's why we do cursor.lastRowID. So now that we're able to get all the subtasks and insert data into the subtask table, we should be able to get a subtask by its ID. So we can make a method for that. We get the cursor, and we can just get subtask wherever the ID is equal to what got passed in. And this is pretty standard, doing the same thing here. And otherwise, we would just return none, because it means we didn't find that subtask. All right, great. So now that we can get all the tasks, insert data, and get a task by its subtask by its data, we can finally see the fruits of our labor, which is the whole point of this, referencing subtask by a task. So let's get all the subtasks by a task. As usual, you want to get your cursor and execute some command. But instead of wherever the ID is something, we want to get wherever the task ID, and this should be lowercase, is that ID that we're expecting. So note that this ID is task ID and this ID is subtask ID. You might want to rename that for your own sake, but that is the difference. So we can use parse cursor again. This is just getting that data. And then at the very end, we can return all of those subtasks. Great. So we have all these methods in db.py. The reason that we abstract this is because the app.py can just focus on handling the routes, the clients, sending the error codes, the messages, and db.py can just focus on the database. And what's nice about this is if you ever decide that you want to change your database implementation, you can very easily because you've already abstracted that layer out. And now we can go to app.py and make those routes for the subtask. All right, so the first thing that we want to do is create a route that lets us create a subtask. So we can make this route. So of course we need to know this task ID so that we can reference the subtask to. And this is going to be a post method because our subtask is going to have some information required to be created just like any other task. And we're passing in a URL parameter here, so we need to pass it into our function as well. And now we are getting the JSON body of the client's request. We're getting that description that they filled out in the JSON. And now we're getting that task to ensure that, hey, this task actually exists. Because if it doesn't, we'll just return a failure response. And now we can actually go about inserting data into our subtask table because we found a task ID, so let's create a subtask for that task. And this was just the description, whether or not it was done, and the task ID that it references that we just got. And we can get this subtask to, I guess in some ways it's like a sanity check, like, okay, sure, we've inserted the subtask, and now I'm guaranteeing that this subtask was actually created and returned by my database. So let's do that. If it is successful, we'll just return that subtask we just created. Otherwise, we'll return a failure response. All right, and that concludes just creating a subtask. So we have 2 more methods to go. Let's create a endpoint that lets us get the subtasks of a task. So again, this is like the most important part of why we're having these foreign keys, is so that we can have this connection between what subtasks belong to what tasks. So we can make this endpoint. And this will get all these subtasks of a task by the task ID, of course. And something nice that the database will do is if the task ID doesn't exist, it will just return none naturally. So we don't have to worry about, in the case that the task ID doesn't exist, we can just straight up return whatever the database does. Great. So as you can see, this is actually very easy. You didn't have to worry about much of the logic and handling, whether that task ID was none, how to actually get those subtasks, and that's the beauty of separating things and abstracting. So now we can create a method that can get us all the subtasks, regardless of whatever task that they're tied to. And this can just be in general good for debugging. So let's add that. And likewise, the database will handle any exceptions. Great, so let's test this out on Postman, but before I do so, I just want to make sure I have my semicolons in because that actually matters in SQL. Alrighty. Okay, so let's run this. So I do have my Venv activated, as you can tell right here. And let's run it. So let me remove this database file because that was created in an earlier instance. And let's run this. Great, so it says it's running on localhost port 5000, which is what I expect. And we can go to Postman to check this out. So we can try and get all the tasks, and we should have nothing. So actually don't worry about this body right now. It will be useful later, but right now we're just doing a get request. And as you can tell, the data is empty. So let's create a task. So that's a post. Let's just say do homework is our task. And when we post that, we get an error. Okay, so that was just a naming issue. And it restarted when I updated my code. So if we send that again, it should work. Awesome. So if I get all my tasks, I should see that task I just added has been added now, which is amazing. And let's try to get the task by its ID. And that works. If I do 2, that also works. So let's try to create a subtask. So this would be post, and I know that a task with ID 2 exists. So we can have our subtask be like, do problem 1 of that homework task that we had originally. And we can send this. All right, it says no such table subtask. So let's figure this out. So this is where we're creating our subtask table. Okay, so one thing that's important to note is that we have this foreign keys reference. I'm going to be adding these foreign keys, and you should be able to recognize that they are foreign keys. So glad we figured that out. Let's try this again. So let me remove todo.db. And no, you should only be deleting your .db file if you ever change the, schema of your database, like the internal hierarchy, like what tables you're defining and creating, stuff like that. So great, our task isn't found, but let's try and create a task. And then we can try and create a subtask. Alright, so it says subtask no such table. So it could be something wrong with create subtask table. So let's look at that. So let's see if it reaches. Alright, so it reaches create subtask. I spelled foreign wrong. I did this in lecture 2. Okay, let's try this again. Alright, so let's try to create a task. So let's just say do homework. And then let's try to create a subtask. And let's just do problem 1. Get subtask by ID. Alright, so this is by ID. There we go. And then if we do this again, so let's do homework. Then let's create the subtasks. And there we go. So with much trial and error, we got it. Okay, and then if I get all my subtasks, I should see all my subtasks. And if I get a subtask by ID, I should be able to do so as well. So that's just... Oh, we didn't implement that. So we just only did get subtasks of task and get all subtasks. So let's try and get all these subtasks of task 1. Subtasks. And there we have it. Alright, so hopefully this video was helpful. the demo. If it went fast, let us know in the feedback, but otherwise we'll see you next week.